Hello everybody. In this video, we are going to be determining the equation of a linear function. So this is actually more of an introduction, once again, to the linear function. Okay, otherwise let's get started. So we need to analyze this function firsthand, okay? So we know that this y actually just indicates what will the output be, right, on the y-axis. And this x indicates the inputs, the input value that we place into the function to get the output. However, we have two other parameters within this function. So we have something called the gradient. We call this the gradient or the slope. Essentially what this means is how steep is the function, meaning that is the direction of this line steep, or is it not that steep, or is it going to be flat? When it's flat, that means there is no steepness, meaning this gradient should be 0, right? That's based off of intuition. We'll get into that soon. Okay. So that is gradient or slope. This looks very interesting to be a forward slash. There we go. That looks better. And then here we have the c, which is the y-intercept. Okay. This indicates where the function intercepts exactly on the y-axis. Okay, so this is the whole analysis of this function. We just know that this is a line equation which goes in a certain direction depending on the gradient. Now let's actually get into the types of gradients that you will get and how to indicate whether something is negative, positive, or whatever else it may be. Okay. So here are different types of line shapes that we can have, okay? So obviously this can vary. Let's look at the top left. This can vary depending on the steepness, but in this case, the steepness is just at its default, which is 1 for this example, okay? So notice I was just going in a perfect diagonal line, okay? So when we see the function is from left to right, we always look from left to right when it comes to functions. What we notice is that it increases from left to right? Meaning that the gradient should actually be positive, right? Because if you think about it, the output needs to become bigger. The higher the number, the higher that the values get, right? So therefore, the gradient would have to be positive in this case here. So I'm going to say here that the gradient is greater than 0 for this type of line. Okay. For the next type of line, we can see it's decreasing from left to right. So notice how the values of y is actually getting smaller and smaller from left to right. So meaning the more x values that we input, the higher the x value will be, the lower the y value will be. Meaning that the value of the gradient must actually be negative. The parameter of gradient really needs to affect the output in some way. It needs to correlate somewhere, okay? And in another video, we'll actually be going over the effects of parameters. However, in this video, we are going to be dealing with linear functions on its own. So that means that this gradient needs to be small. It needs to be negative, okay? Strictly negative. And what about this? What do we notice about this line? Well, there's no steepness at all, right? Do you see that it's just going in a straight line? Like, think about it, right? If you are in the roads of just like a standard road and you're just walking, and you can notice that there is no steepness, right? You're just walking in a straight line, so it's easy to walk. However, if you're in the roads of Plattekloof, then you might actually have to be obviously putting in more energy to walk, but at the same time, notice that there are a lot of inclines, meaning that it's just steeper roads, okay, which means you need more energy. So obviously the gradient of those roads will be higher. Unless if you're going down, then obviously the gradient will be lower, okay, because then it will be a decline. However, with this means there's no steepness, meaning there is no slope, meaning the gradient must be 0. Okay, because there's nothing, no steepness at all. But what about this? Imagine having to walk up this. You can't, you have to climb this. This is a wall. So the thing about this one, right? This just indicates that there is no actual like proper slope. If it's a perfect straight line that is vertical, then the gradient has to be undefined, because we can't really get to some slope that is exactly vertical, meaning that the gradient is undefined. I can't even spell. Undefined. There we go. Cool. Now that we have the idea of shapes and what straight lines look like, we need to know how can we actually like apply these gradients. Well, there is actually a formula for the gradients, and let's look at it below. Okay, so here we are, right? We have the gradient. The formula for the gradient is the following. It's y2 minus y1 is all divided by x2 minus x1. Now, this formula actually comes from some idea where we have something such as a run and rise, right? So let's say, for example, we have a distance between maybe 2 points, okay? Let's say that this point here, we'll just set a point right here, okay? And then we'll also set another point, let's say somewhere here. It really doesn't matter where the 2 points are. And then we'll call this coordinate x1 and x2, okay? And we'll call the other coordinate, well, not really x1 and x2, sorry. It'll be x1 and y1. And then the other one will be x2 and y2, okay? So it'll be the first set of coordinates of x and y, and the second set of coordinates x and y, okay? And notice that you can see this goes all the way to here, right? But we need to determine what is the steepness of that slope. How do we get the steepness? Now treat it as if we just subtended a right angle triangle, and I will show you why we're doing this, right? So we need to subtend some right angle triangle, okay, such that what we notice is that this is something that we call the rise. Why? Because it's obviously like rising, it goes up. And then notice that this rise has a distance or a height of y2 minus y1. Notice that it has a vertical distance where the unit over here is y2, and then the unit over here is y1, and then the height between that is just going to be the difference between them, okay? And then we have something else which is called the rise, and I'm going to just write here, oh, not the rise, the run. Why? Because it's, I mean, when you run, you usually run horizontally. You don't run upwards into the sky. So we run horizontally, and notice that's just the distance or the difference between the x values. So the first one here is x1, and then notice that x2 is somewhere here, meaning that that's just going to be the difference between x1 and x2. So that we have this. However, what we notice is when we divide these two together, we are going to end up getting some type of gradient slope, okay? And if we look at it in that way over here, if we look at it in that way, we'll actually be able to get the steepness of the slope, okay? If we use the proportions of the right angle triangle. So in this case, if I create up two coordinates, let's say, for example, that this coordinate is going to be equal to, let's say, okay, it must make more sense. So this should be, let's say, 3 and 2, okay? And let's say that this coordinate is equal to, I can do that a little bit there. Let's say the y value should be negative, so negative 2, and let's say maybe negative 1, okay? So we have negative 1 and negative 2, all the way to 3 and 2. So meaning all we're going to do is substitute that in, right? So this actually just tells us that the gradient is equal to, what is y2? Well, y2 is just the y value of that coordinate, which is 2, right? 2. And then here we're going to have y minus y1, and notice y1 is negative 2. So we take in negative 2 as it is, and don't forget about the bracket, because remember that there's a minus, and 2 is actually a negative in that case there. Then we have x2 minus x1. Notice we actually get x2 over here, which is 3. So it's going to be 3. And then we're going to have x1. We're going to subtract x1. And notice x1 is just going to be negative 1. So it's going to be minus negative 1. And therefore, m is just going to be equal to, if we simplify it, it's going to be 2, negative, negative gives a positive, so it's plus 2 divided by 3, negative, negative gives a positive, it will give us a 3 plus 1. And then therefore, our gradient of this slope should, or I guess the gradient of this certain function called f, is just going to be 4 divided by 4, which is equal to 1. Okay, so this is a standard slope of a standard function, y equals x. Obviously minus something, because we clearly have a y-intercept over here somewhere. Okay. All right. Good things come ahead here. So let's go into an actual example of how we determine an equation by using this understanding of gradients and also trying to find the y-intercept. Okay, so here's our first question. Example 1 says, determine the equation of the line below. So, first things first, I did not label it. I'm sorry about that. F. Okay. So, the function name is f. And what do we notice about the slope? The slope is going down, and it's pretty steep. So, which means it should be negative, and it also should be quite a decently high number, right? Obviously, okay, I did not really draw it according to scale, but we can actually find the equation just by using 2 points, okay? So now let's look at the following. Okay, so first things first, what we can do is the following. We can label these as either x1 or x2 or y1 or y2, okay? So we need to label the coordinates. It really doesn't matter what order, by the way, that you choose. You can choose this one to be your first set of xy coordinates, or you could even choose this one to be your first set. But usually it's easier if you just do it from left to right, okay? Or you could do it from up to down, so meaning the lowest one you can set to the first set, and the highest you can set to the second set. It really doesn't matter. So I'm going to do it from left to right, just so it's like easier, right? So we'll call this x1 and x2, x1 and y1, okay? And we'll call this x2 and y2. Okay, cool. And now from here, we can just substitute that into our formula. Remember that our formula is going to be the following, right? Y equals to mx plus c. So meaning, what we need to do is we need to find the gradient first. So the first approach is to find the gradient. Then we need to also find the y-intercept, okay? Because the x and y are just like variables, inputs and outputs. So we don't actually determine those because they're already within the domain and the range of the function, okay? So now what we are going to do is, we can get started. So the gradient is going to be equal to, remember, it's y2 minus y1 divided by x2 minus x1. And we know that that's just going to be the same as, what is y2? y2 is equal to 4, negative 4. Minus, we have y1, which is 5, divided by x2, which is a half, minus x1, which is negative 1. Okay? Meaning that this tells us that the gradient is equal to negative 4 minus 5, which is minus 9, divided by a half minus minus 1, so that's a half plus 1, which is just going to be equal to 3 over 2. And we can tip and times this, and we can say this is the same as negative 9 over 1 multiplied by 2 over 3, and then therefore the gradient is just going to be equal to negative 9 multiplied by 2, which is equal to negative 18, and negative 18 divided by 3 is just negative 6. Okay, so you can see that this is a negative gradient, which is perfect. If you can see that the shape correlates to what you have, then you are in the right track, and it is a decently steep slope, which we can see over here as well. So having a high number such as 6 makes a little bit more sense. Okay, cool. Now that we've found the gradient, we need to actually determine the y-intercept. Now remember, I guess let's first write down what we have so far. We have y is equal to negative 6x plus c, right? Because now we know our m value. Our m is negative 6. However, we need to find c. And how do we find c? Well, notice we do have points on the function. that we can substitute in. Okay, so remember, usually whenever we're dealing with functions, we plug in an x value and we get out a y value. However, we note that if we have some coordinate that has an output and an input that is given to us, we can just plug it into both of them into the function, and then we can find our missing variable. Is that not so? Because then it actually correlates to the exact line that we're dealing with, meaning that our c value has to be the one for our graph. And our c value should be a negative value, because you can see here that the c value is right here. Remember, it's the y-intercept. This should be the y-intercept, which is c. So let's solve for c by plugging in one of the points. We can plug in any point as long as it's not a x-intercept. Okay. So here, the easiest point to plug in is the one without the fraction. So it means it would be better to plug in the -1 and 5. So we're going to tell the teacher here, we're going to substitute -1 and 5, the coordinate, into that. Okay, and notice that obviously this is the x and this is the y. So we substitute our y value, which is 5. And then here, this is equal to -6 into our x value, which is -1, plus c. And then we solve for c, right? C is just going to be equal to, we take this over, -6 times -1, which is +6, and then 5 minus 6, which is equal to -1. So c should be equal to -1. And yes, that should be true as well, because notice that it is negative. So therefore, we're going to have y is equal to -6x minus 1. And that is going to be the equation of our linear function. Okay, and here's our last question that we're going to be dealing with, okay? So if it is given that the coordinates 0, 2, and 1, 6 are points on f, determine the gradient of f. So meaning we are given 2 points, okay? Now, notice that the points that we were given, okay, this is actually a very straightforward question. It doesn't even take that long to finish, right? It just looks a little bit interesting because it's just words and then didn't give a function. So let's put this into retrospect, right? We have a function from this. We can actually form a function. If we have 2 lines, right, at least 2 lines. Did I say 2 lines? If you have at least 2 coordinates, you should be able to draw your line function, okay? You need at least 2 coordinates in order to sketch your line function, which is kind of a hint for when we are sketching line functions in the next video. So let's draw this function, okay? So if we have the following, it's a very not line looking line. Quote that one, by the way, put that on the 2026 quotes of the year. Okay, cool. What we have is a line function over here, and let's make that red. Okay, so we have 2 points. It is going to be 0, 2, meaning where x is equal to 0. So let me rather draw my axes. Remember, whenever you're sketching, you always have to do the x and y indication, because sometimes they'll read it incorrectly. I know they're not stupid, but at the same time, you need to have reasoning behind your work in order to get all the marks that you want and to get out of the position that you're in faster and not repeat the error. Okay, anyway, so 0, 2, where is that? X is equal to 0 is exactly going to be, it's going to be this specific position, and then it's going to be where y is equal to 2. So meaning, let's put that here, okay? So this coordinate will be here. So it'll be 0 and 2. And then 1, 6 will be maybe somewhere here, where y1 is here, and then we have, let's say 6 is somewhere here, okay? So this will be 1, 6. And then we're just going to draw our line, okay? So our line will look something like this. And we must make sure that it connects to the other point. And then we can obviously continue it from here. Okay, cool. And we're calling this f, right? This function's name is f. So here we go. Here's our line function that we have here. And notice we have 2 points. Now, you could go ahead and find the gradient with these 2 points. However, what do you notice about this? We actually have a y-intercept, okay? So I'm trying to keep you a bit open-minded here in terms of these types of questions, that you can actually just take an easier way out. Notice that this 2 is actually the y-intercept, okay, because it's the value 2 on the y-axis, meaning that our equation is going to be y is equal to mx, and then we are going to have plus 2. Okay, we have mx plus 2 because the y-intercept is positive 2, meaning c is equal to positive 2. And notice that we have a random point, meaning we don't even have to use the gradient formula, right? So all we have to do is just substitute this coordinate, because it's a part of the same line, into this equation, and then we can solve for m. Because remember, we already have our y-intercept. So we only have the m to solve for. So we're going to tell the teacher, we're first going to, on the paper, just drag this. We're going to select our graph, and we are going to shift it over. So if you have an examination paper, don't forget to use this trick. It's very neat. Okay, I use it all the time. So we need to sub in the random point 1 and 6, okay? So then from here, what that indicates is that we're going to have our x value, which is 1, and our y value, which is 6. Therefore, we'll have 6 is equal to m multiplied by x, which is going to be 1, and it will be plus 2, okay? And then we just solve for m, right? We take the 2 over, and then what's going to happen is it's going to be 6 minus 2, which is equal to 4. Is just equal to m times 1, which is m. So which means you're going to be left with m is equal to 4. I just like it when the m is on the other side. I don't like it when variables are on the right side. It looks weird. So there we go. We therefore found our final gradient. So therefore our equation, remember it's in the form of if, so which means we need to find f of x is equal to 4x plus 2. Okay, so don't forget about that part. And I've actually forgot about it in the other one, where the function was f. So this is actually supposed to be f of x, because you'll notice that the inputs are x over here. So it'll be f of x. Okay, and then same with this one here. So there we go. That is how you find the equation of linear functions. Pretty straightforward.